Think about the huge, interconnected rail networks that are basically the arteries of our world, moving people and goods across borders every single second. They're absolute marvels of engineering, right? But they're also way more fragile than you might think.
It almost always starts with something that seems tiny. A little technical glitch, a broken switch, or, like the research for this explainer points out, something as simple as one signal failing in one country.
And just like that, the ripple effect kicks in. That one failure in France, it can bring high-speed trains to a dead stop, leaving passengers completely stranded in places like London and Brussels. And this isn't some made-up scenario. It's the reality of how our modern borderless rail systems actually work.
So let's dig into this idea of the one broken link. How do these massive cascading failures even happen?
What's so wild about this quote is how simple it is. Researchers have been pointing this out for over a decade. The problem isn't just that one train is going to be late. No, it's that the failure of a single piece of track, or one signal, can set off a domino effect that sweeps across an entire continent.
Right? So this is the big question we're tackling today. Because it's not just about a cracked rail. The real vulnerability, the real weak spot, is buried way deeper in this hidden web of connections that most of us never even think about. And that's exactly where we're going next. We're going to peel back the layers and take a look at this hidden web of dependencies.
So here's the crucial thing to understand. Our rail systems aren't just connected by tracks. They depend on each other in at least 5 really important ways. First, yeah, you've got the obvious physical stuff, the tracks, tunnels, and bridges. But then there are the operational dependencies, things like making sure schedules and crew rules line up across borders. After that, you've got the digital systems, the signals and communications that have to, speak the same language. Then there's the supply chain for parts and fuel, which has to work flawlessly. And finally, holding it all together is this incredibly complex web of legal and financial agreements that decide who pays when it all goes wrong.
This image does a perfect job of showing what happens when one of those dependencies just snaps. See that disrupted terminal marked A? Suddenly, the operators have 3 choices, and honestly, they're all bad. They can try to reroute everything, which creates absolute chaos. They can just hold the shipments and wait, creating a massive backlog. Or they can hire a super expensive third party to try and fix the mess. Now, things break, it happens. But it's not always an accident. Sometimes it's deliberate. So in this next part, let's ask, who are the people actually trying to break the system? The research really breaks this down into 2 main groups of bad actors. On one side, you have state actors. We're talking governments or groups backed by governments. Their goal might be political, to pressure another country, and their favorite tool is often a sophisticated cyber attack on the control systems. Then on the other side, you have non-state actors. These are terrorists, criminals, even protest groups. Their goals are different. Maybe they just want to cause chaos or steal something, and their methods are usually more direct, like physical sabotage. But of course, it's not always some shadowy figure causing the problems. The system is vulnerable to all sorts of things. You have the deliberate attacks we just talked about, sure, but you also have man-made issues like strikes or protests. And then there are natural disasters, simple equipment failures, or just plain old human error. And here's the scary part. The network doesn't care why it broke. The cascading failure can look almost identical no matter what caused it. Okay, this all sounds pretty bad, but let's talk numbers. What's the actual price tag on this chaos? Let's get into measuring the damage. Just take a look at that number, $3.2 million. And get this, that number comes from some serious economic modeling. It's the estimated extra cost, on top of everything else, when just one single critical rail terminal goes completely dark, for just one incident. And eventually, you know where that cost ends up, right? It means higher prices for goods and more expensive tickets for all of us. The economic shockwave goes far beyond the rail yard. But it's not all doom and gloom. The same research shows that being proactive really pays off. On this chart, the black bars show the extra cost of a disruption. But look at the pattern bars. That's the potential savings from having strategies in place beforehand. For a major hub, investing in resilience could save over $4 million when a total shutdown hits. So the takeaway here is huge. Yeah, failure is expensive, but investing in being prepared, that pays for itself big time. So, how do we actually do it? In our final section, let's look at the strategies for building a resilient railroad. So, when a disaster strikes, operators have these 3 immediate moves. They can try to reroute, hold everything, or call in that third party. And like we said before, That third-party option is almost always the most expensive, but sometimes it's the only way to keep things moving. But these are all reactions.
The real goal isn't just to get good at cleaning up a mess. It's about mitigation. It's about taking steps before a crisis ever happens to make the whole system stronger so that when something does go wrong, the impact is way smaller.
And this gives us a great idea of what that actually looks like in the real world. The research highlights a few key strategies. Operators can make deals to rent space from their competitors during an emergency. They can build smaller backup terminals. They can boost the capacity of their less important hubs so they can handle any overflow. Or they can design totally new routes to create backups and avoid putting all their eggs in one basket.
And all of this leaves us with one final big question. Our rail networks, just like so much of our world, are getting more and more connected every single day. So we have to ask ourselves, is all that connection making our systems stronger and more resilient? Or are we just creating more and more ways for the whole fragile chain to fall apart?